Hello, in this video I will introduce you with a new feature-based drilling in SprutCAM 9. So let's start. To create a new FBM mill operation, just selecting from this menu. Now we see the feature tree. We have to refresh it. Now we see the features in this part. The features are sorted and grouped so that the features with the same parameters have the same color. You can change the grouping scheme by drag and drop or by checking the boxes in this pop-up menu. So we disabled grouping by plane, and now we see all the feature configurations that this part has. So, how to create operations? The easiest way is just select a feature in the graphic view, then click on its name, then hover the cursor of the Add Operation menu, and we see all the operations that are applicable to the selected features. Let's add spot drilling and finish drilling. Now the edit operations can be seen in this list. In this list I can rename operations, I can delete operations, I can reorder operations, I can change the tool number, I can create a new tool, I can change the tool itself. All the changes I make here are automatically reflected in the generated operations list. So let's add another hole. Let's do hole pocketing, and this is a 3-step hole, and here we have available operations for each step. Let's add simple drilling for the step 3. This tool isn't present in the tool database, it's a missing tool. We create a new tool. So now we just recalculate the operations and we see the tool paths. It's a spot drilling, then finish drilling, then hole pocketing. You can see here that hole pocketing makes pockets in the step 2 and 1, and then we have finish drilling. Now let's create operations in another plane. We just create a new FBM mill group, and let's do machine from this side. Let's do hole pocketing and and let's do some chamfer in this hole. Then do the same with this hole, pocketing and chamfering, and do pocketing here. And this hole looks like a threaded hole. So let's spot drill it, then finish drill it, and then make a chamfer, and then tap it with M4 tap. And this hole looks like a hole for a screwdriver. So we have a strategy for it. It's a drilling and spot facing. And calculate. Now we see that we have hole pocketing of these holes, then spot drilling, then finish drilling, then chamfer contouring with the same tool. Chamfer contouring is a new cycle. It is axial tool shift 1.5 mm and radial tool shift 0.5 mm. It means that the chamfer is of size 0.5 mm. We can reduce it to 0.1 mm because 0.5 mm is too big. And axial tool shift, let's say it will be 0.2 mm. Now recalculate. Okay. How does it work? It works very simple. Here we see a button, procedures library. When we press this button, we see all the procedures that we have predefined in SprutCAM. A procedure is a small machining sequence that machines one feature. Let's create a new procedure. So, its procedure may recite one of the libraries. System, all users, and personal. System is the library that is provided with SprutCAM installation. All users is the library that resides the all users directory, and personal is the library that is in the My Documents folder. So, a procedure machines some feature. We have to select feature type at first. It may be now either a whole or stepped whole. Let's do a whole procedure. So, a whole is a feature that has some parameters, and we say here what parameters should this whole have. It has to have a taper angle of 0 degrees and diameter of any diameter. Let's say this hole has to have a chamfer. It means that the chamfer size should be greater than 0. Okay, now let's say this hole is a through hole, and oh no, let it be any hole. So, and let's say that this hole is not too deep. It means that height to diameter ratio has to be less than 4 millimeters, less than 4. Okay, now we specified the parameters of the hole. Now we say what operations and what tools will be used to machine this hole, and how many of them. Let's say that this is okay. What we make is a procedure to machine a threaded hole, metric thread, I say. Okay, let's name it so. Metric thread hole. Okay, and let's say we will be machine it with 3 operations. At first we will be spot drill and make a chamfer in the same operation. Then we will drill it through, and then we will make a tap with a tap mill or tap drill. Okay, it's at 3 operations and 3 tools. Okay, the first tool will be a spot drill. A spot drill, and the diameter of the drill must be greater than the diameter of the hole plus chamfer size. Let's write this down. Greater than hole diameter plus 2 multiple hole chamfer size. Okay, and working length, it could be any, and angle could be any. Okay, any. Okay, the next tool will be simple drill. Yes, where it is here, and diameter of the tool has to be less or equal to the hole diameter, because we make a threaded hole. So a length could be any, and angle could be any, and working length has to be greater or equal to the hole height. Okay, now the third tool will be a tap, and the diameter of the tap is an interesting question, because many CAD systems design holes for taps, and the diameter of the holes is not the same as the diameter of the tap. For example, for a metric 12 M12 threaded hole, it is usually the diameter of 10.47 millimeters in a CAD model. So to reflect this rule, we have to specify a range. Basically, I think that the diameter of the whole thermometric tool for a metric tap thread is in range of 1.1 multiply whole diam to 1.3 x whole diam. Okay, length could be any, working length any, and working length should be greater or equal to the whole height. Okay, so now we have three tools, and now we have to define operations. Okay, the first operation uses the first tool, and it belongs to the preparing group because it's preparing operations. It makes a spodule and then chamfer. So it has a caption. Caption will be chamfering spot and chamfer. Okay, and chamfer. Okay, cycle. Cycle is a small operation that machines the future. We have now the following cycles: simple drilling with well, drilling with chip removing, and so forth and so forth. Okay, we will use drilling with well, and with NC code format can cycle and top and bottom level. What are they? Okay, let's say the top level will be the topmost hole level, and the bottom level will be determined by feature, and that's enough. Yes, and bottom well will be 3 revolutions. Okay, now the second operation is simple drilling, so it uses tool number 2, and it's a finishing operation, and it has a caption of drilling. Okay, and cycle is simple drilling, and the third operation uses the third tool, and it is a completive operation because it's the last, and the cycle is simple tapping. Okay, we have tapping here, so I think that should work. Okay, we have our hole and we have our metric sheet, so now we can create 3 operations in one click, and they will machine this hole. Okay, we have the spodule that makes a chamfer in the same move, and then we have drilling, through drilling, and then we have tapping. Now, what's next? Let's simulate. Okay. Okay. Yes. Now I want to show you some details. First of all, how operations are created and in what order. When we define machine sequence for a feature, we add some operations, and this operation is added to the job assignment of this IBM Mill group. Now every feature has assigned machine sequence, and those information is the input data for generating resulting operations. Let's add here spot drilling. It's not necessary, but it's useful for demonstration. Okay. Now we have spot drilling here that uses tool number 1 and spot drilling here that uses tool number 1 too. So, and we see that the generated operations, it's only one operation for spot drilling that uses this tool, and we put all the holes in this operation, these and these. That's interesting thing, because what we have here is not actually whole machining operations, it's a universal milling operation that machine features. The universal means that this operation doesn't know anything about the features it machines. All the information about the strategy is stored in the job assignment. I mean, the parameters of operation are stored in the every feature. Here we have the multi-select, and here we change those parameters. If none of features are selected, then we edit all parameters of the all features that these operation machines. And if only one or several features are selected, then we edit the parameters for only this feature. For example, let's say that for this hole, depth of cut is not 10 but 50% of tool diameter, and recalculate. Now we see that this hole is drilled deeper than the rest of the holes. Okay. How operations are generated? The operations are generated in such a way to minimize tool changes, because the following option is enabled, but we can disable it. And if we disable this option, then the operations are generated in the order we have been added the features to the job assignment. At first we edit those features, those holes, so we have the spot drilling first, then we have finish drilling of this hole, and then we move to the next hole we've been adding, and we make at first spot drilling and hole pocketing, and then finish drilling. You see that the order of machining is not optimal, because we have spot drilling with tool number 1 here, and then tool change to tool number 4, then when tool change to tool number 1 again, and this is not optimal. That's why we have the minimize tool changes option here. If we enabled it, then SprutCAM automatically reorders operation in such a way that to minimize tool changes. So now we have spot drilling only one operation for spot drilling, and there is no redundant tool changes. Okay. Now we have yet another option. It is called Unite Operations with the same tool. If we disabled it, then SprutCAM still reorders operations such a way to minimize tool changes, but it doesn't unite operations. So now we have two spot drilling operations that follow each other, and the first operation machines diameter 3 hole, and the second operation machines the 3-step hole. But those operations are distinct operations. Okay, that's clear, I think. Now, how to edit the parameters of the operations? The only way is to edit parameters in the inspector. Here you can change the type of cycle that is used to machine this feature, and you can change the parameters of this cycle. It is at first the NC code format. In what format will be output the result? It could be a cycle, or it could be a longhand format without a cycle. And for every cycle we have parameters. Basically, for whole machining cycles we have parameters for top and bottom levels. If you click the top or bottom level, you can see the preview. So you can easily see the result, even not calculating the toolpath. For example, this is spot drilling, and we changed. It's a simple drilling. That's why the bottom level is set to by feature, and the tool shape is bigger than the hole itself, so it stopped here. Let's say we want to make a chamfer, then we have to add some stock. Let's say it will be -1 mm, so we make a chamfer of 1 mm. It's too big. Let's say it will be 0.2 mm negative, so we make a 0.2 mm chamfer. Okay, and for every cycle we have also parameters that are specific to this cycle. For example, for threaded hole or tapping, we have the parameters that are specific for tapping, like thread pitch, spindle position, and so forth. I think that's it. I think that's it for now. Okay, thank you for your attention. Bye.